The plan that I had is to first share with you some results from an international collaboration of pregnancies exposed to these GLP-1 medications. And then as we do that, also discuss the opportunities and also challenges of using real-world data for evaluating the safety of medications during pregnancy in this field of obesity and diabetes. So obesity and diabetes are among the most common medical complications that we confront in pregnancy. In the United States, the prevalence of obesity by 2018 was around 40% among women of reproductive age. That's 10% higher than a decade before, when it was around 30%. And among those that conceive, which are a little bit healthier, on average, right, the prevalence of pre-pregnancy obesity is 29%. And regarding pre-gestational diabetes, the proportion is around 1% of pregnancies entering with pre-gestational diabetes, and over 50% of them in the US will be diabetes type 2. And both obesity and diabetes in particular are known to increase the risk of a wide range of adverse perinatal outcomes, including in the mother, like maternal death, preeclampsia, macrosomia, which is excessive fetal growth, and resulting in labor complications, cesarean sections, C-sections, and also in the infant, we have spontaneous abortion, stillbirths, prematurity, and congenital anomalies in the fetus. And for the treatment of diabetes outside pregnancy, so in the general population, these medications, the glucagon-like peptide-1, those are the GLP-1 receptor analogs, have gained acceptance because they do work pretty well and they are well tolerated, particularly if the alternative for diabetes is insulin, that comes with certain complications and difficulties to use, as you might know. And for obesity, more recently, some of these GLP-1s have been approved by the FDA and other regulatory agencies, specifically for weight loss. But the FDA emphasizes that the indication is when diet and exercise are not good enough to reach the weight loss goals, and that the use has always be in combination with lifestyle changes, including healthy charts for the use of these medications for obesity. So if you notice in this chart, the pink line, Saxenda, which is liraglutide, is one of the LGP-1s. And after approval in 2014, you see how it started going up. By 2018, was already like the most commonly used anti-obesity medication other than phentermine. So the GLP-1 receptor agonists, I find analogs, I find it very interesting that how they work is by stimulating the GLP-1 receptor in the brain. So they are like neuroleptics, actually. And by doing that, they produce a feeling of being full and not craving food, and actually not craving other things, probably. So they act in the brain, and by doing that, then you don't need to eat, you don't feel that you need to eat, and that's how they act in weight loss. By this year, by 2024, there are a number of GLP-1s that have been shown to reduce body weight and also reduce hemoglobin A1C that we use to measure glycemia in the blood in individuals that are overweight or obese, including those that have diabetes. And the list of medications that we have available right now include liraglutide, semaglutide, and more recently, a new medication, tirzepatide. And recent results have shown that not only these medications reduce hemoglobin A1C, that you might consider a surrogate or even weight loss, that also is not the ultimate outcome, but there are recent studies showing direct effects on the heart outcomes of interest, if you wish, so beneficial effects on cardiovascular outcomes, and also some safety signals have started to appear in the general population. In pregnancy, the periconceptional use of GLP-1 receptor analogs is also rapidly increasing, particularly in the US. And so here you have a graph showing the use for the treatment of type 2 diabetes, because by the year 2020, 2021, most of the use in pregnancy had been like 1 year before, and therefore, in theory, was for diabetes. So you see results for the Nordic countries, the US and Israel, and I will tell you why in a second. And the green line are the GLP-1 analogs. So in the center, you have the data from the US, and you can see how overall any GLP-1 analogs were exponentially, rapidly increasing when we look at the prescriptions dispensations during the first trimester of pregnancy. And after approval for obesity, we expect that these numbers are going to increase rapidly in early pregnancy, and that is going to result in an increasing number of infants exposed prenatally. So these are some preliminary numbers from a market scan in the US, showing the utilization of different medications for obesity. And you see in light blue, the liraglutide use, that's the GLP-1 that was approved earlier. And in orange, you see the semaglutide use that is increasing really, really quickly, even like just by 2021. So the use is going to increase, and we don't have much information on whether these new medications are teratogenic or not. And this use extends into pregnancy, not necessarily because the patients were taking them on purpose during pregnancy, but because around 0.5% of the pregnancies are unplanned. I'm not saying unwanted, just like not planned at that right time. So many women conceive when they are on these medications. And moreover, these medications can improve fertility when they have good effects, beneficial effects on obesity and even on PCOS. And therefore, even a higher proportion of pregnancies are going to conceive on these medications unintentionally. We have also observed that after realizing pregnancy, the dispensations and prescriptions really decrease. And for diabetes in particular, the recommended medication for diabetes in pregnancy has been for decades insulin. So here you have a graph where we describe how, if you look at insulin in purple colors, with or without other medications, pre-LNP and in the second trimester, we see a change, a shifting of the medications from anything the patient was taking to insulin during pregnancy. So when we look at the other anti-diabetic medications other than metformin, including the GLP-1s, they are down in blue. We see that most of the user pre-pregnancies will switch to insulin and will discontinue using these medications. So this pattern, I think, is important for you to think and the kind of thing that we can evaluate during pregnancy. So, of course, we prefer to base our decisions in terms of the treatment in any population based on randomized trials, but because pregnant women are typically excluded from clinical trials, the safety of these medications during pregnancy and for the fetus is largely unknown. There were a few pregnancies in the big trials, large trials, but a handful of them. So, and when we don't have these randomized trials, we can use real-world evidence. So that's one of the reasons why real-world evidence can complement and sometimes replace randomized trials in the populations that are excluded from them. And that's the case of pregnancy. So we need to produce information as soon as possible on the safety of these medications, because an increasing number of pregnancies are going to be exposed, and the prescribers are going to get the question, do I have to worry about this? So with that in mind, we designed a study to evaluate whether preconceptional use of second-line non-insulin anti-diabetic medications, including GLP-1s, increase the risk of major congenital malformations in the infant. This project was led by Dr. Caroline Sesta, who was here with us during a few years, and now she's back at the Karolinska. And it was a collaboration among all the Nordic countries, the US and Israel. And by the way, I'm taking these slides from Dr. Sesta without permission. But so we put together the data from Finland, Iceland, Norway, and Sweden, the market scan, which are privately insured women in the US, and a healthcare system in Israel, the second largest, the Maccabi database, for a total of over 3.5 million pregnancies. And this slide also from Dr. Sesta presents the general design. So we consider the prescription or prescription fills, dispensations of these anti-diabetic medications in the first trimester, and also part of the analysis also include the prescriptions the 90 days before the beginning of pregnancy that we identify by the last menstrual period, and then look at the diagnosis of malformations in the infant after birth. We only have live birth data. We consider all second-line non-insulin anti-diabetic medications, including the GLP-1s, and compare them with an active comparator, insulin, that is also used for as a second-line treatment for diabetes, and estimated the relative risk 95% confidence intervals. Adjusting for all the key analysis, we were able to adjust given that the numbers were relatively limited. So this is a table with selected characteristics in the population. This is for the US in particular. We look at within each of the three regions. And sorry for the busy slide. We can focus on, for example, for overweight obesity in the US, those on the GLP-1 analogs, 48% had a diagnosis recorded of obesity in the records during the 3 months before pregnancy. We know that the sensitivity of the claims for obesity is around 50%, although the specificity is really high, it's like over 87%. So we know that we are under-recording, ascertaining obesity in this case. But I think it's be pretty similar between the GLP-1 and insulin, and we see, as expected, that a larger proportion of those on GLP-1 analogs within those with diabetes had overweight and obesity. So we adjusted for these characteristics. And these are the results. This graph presents the prevalence of any major congenital malformation. For reference, as a reference, you have at the top among those with without anti-diabetic medications. So it's around like 4.3%. Those on metformin only, which tend to be less severe diabetes. Those on insulin, then sulfonylureas, DPP-4s, and the GLP-1 analog. So as you can see, wide confidence intervals, but compared to insulin, a little bit above, we did not observe a clearly elevated risk of malformations for these analogs. And in this table, you can look at the relative risks. Crude and adjusted didn't change that much once we restricted to those with diabetes and compare with a similar treatment with indicated for similar, relatively similar patients. So the adjusted relative risk range from 0.72 to 1.26. And specifically for cardiac malformations, the results were similar in the sense that we did not find a signal of we have to worry about malformations with these medications. So in conclusion, compared to the standard treatment for type 2 diabetes in pregnancy, which has been insulin in the last decades, we did not observe an elevated risk of malformations for any of these non-insulin second-line treatments for type 2 diabetes, including the GLP-1 analogs. But while reassuring, because of the wide confidence intervals, confirmation from other studies or from our own studies, but with more data in a few years, is clearly needed. So we'll be monitoring, and I know that others will be also trying to produce more data so that we can have more precise estimates. What is next in terms of research in this field? Now the use is exploding for obesity and overweight. So the numbers are going to increase, and we can hypothesize that because these medications seem to work really well reducing weight, it may be that if they are used as anti-obesity treatments in preparation for pregnancy, they might actually improve maternal cardiometabolic health prior to conception among those that are planning pregnancy, and then reduce all these obesity-related pregnancy complications that we mentioned at the beginning. There is no direct evidence, so that's something that is challenging to evaluate, but will be an important piece of information. And of course, then there is the safety. We presented preliminary numbers, really small numbers on malformations. That's not the only safety outcome that we can look at. So more safety data will be also needed in order to put together the potential risk and benefits for the use around pregnancy and even extending into pregnancy accidentally or on purpose. So for the next slides, I'm going to focus on the use like limitations, or to discuss with you why is causal inference harder during pregnancy, and also during the discussion, if you have any recommendation or ideas to do this better, approach these topics better, that would be really helpful, because we do want to keep trying to contribute information. So in pregnancy, we have problems with the selection when we have to condition on conceiving and then conditioning on live birth. We have challenges with defining our exposure, our outcome, and then we have confounding pretty much like everybody else. That's not particularly worse, and sometimes even might be less in pregnancy. So let's briefly go through each of them to really be transparent to you of what is behind the analysis that we do. First, we have a selection into the analysis. And even if we were doing a randomized trial, we will have this problem in the sense that in order to show you the effects of being on these prescription medications and the effects of in the fetus, we have already conditioned on conceiving. So any potential effect of these medications on fertility, we have to wonder, like, what is that doing to the analysis? And then because we condition on live birth, we then are conditioning on the pregnancy surviving all the way until birth. So you can think about these like fetal losses, abortions, terminations. On the one hand, when they occur before organogenesis, they can be considered competing events with our observation of malformation. So we need the fetus to survive until the outcome in order to observe the malformation. And then, because even after organogenesis, we can have fetal losses and we can have terminations, we also need the fetus to survive with the outcome until birth for us to observe these cases at birth. So just for those of you that enjoy DAX, I try to put this into DAX. So when talking about competing risk, we can consider that if E is the exposure here, and M the malformations, and S are early losses, for us to observe the malformations, if the question of interest is, do these medications E affect the risk of malformation, we are conditioning on surviving until the malformations. So how to deal with these competing events can be the topic of another seminar, but just to disclose that that's what we are doing when we present our data. And then we ascertain the outcome among live births. So that means that we condition on survival with the outcome until birth. So those spontaneous abortions and terminations are not used, and we can have also some sources of bias if they're in the DAG-L are like later losses. If we want to really estimate whether the medication affects the risk of malformations, we would like to have the malformations in all pregnancies and not only on later. So this restriction might, under some conditions, also introduce some potential biases. Then we have information bias of the exposure. The misclassification is particularly challenging early in pregnancy because we can have dispensations and or prescriptions, and maybe right after recognition, the person might stop taking those medications, so we can have false positives. So we can think about the direction of that bias. I think I will propose that it's unlikely to be differential by the type of medication when we are using active treatments, but we can argue that as well. And then we have to worry about looking at the correct etiologically relevant period. So we need the timing of pregnancy to be correct as well. So the solutions for that we use sometimes is to look at those with 2 or more dispensations within the first trimester. Let's say the numbers go down, but those will be more likely to be users since they went ahead and had a second dispensation. And we have done extensive work also improving and validating the algorithms for LNP. So in general, for information bias, one, I think, take-home message is that when we use claims, it's not enough to just look at all the codes and say, if any of these codes, then I have a condition. We did extensive validation of algorithms for each step. This is the algorithm to identify diabetes. So as you can tell, it's not just one code. I don't expect you to go through all the points. And this is work from Molly Good, that was a postdoc here too. So every step took a couple of years for us to complete in preparation. And for the outcome, same thing. We are looking at malformations. We are basing the definitions on ICD-9, ICD-10 procedure codes. Many of them might be suspected diagnosis, that then they might be ruled out, and we might be missing diagnosis. Again, I will argue that differential misclassification of the outcome by the treatment is probably unlikely. The solutions for that that we have been using is to use algorithms with high specificity by requiring not only one code, but multiple codes with surgery or procedures. And then we have validated those algorithms. And with the information from the validation analysis, we conduct a quantitative bias analysis or bias analysis to assess the impact of this misclassification. So this is one example of a validation study by another student, postdoc, doctoral student here many years ago, Christine Palmsten, going back to records to validate malformations, including cardiac malformations, and finding a positive predictive value of above 78%. And finally, confounding, as you probably are thinking, when we are talking about obesity and diabetes, confounding by diabetes progression, obesity severity, when we are using claims where the information on glycemic control is not there, the information on BMI, we have some codes, but we know it's not perfect. Like, can we study this topic using claims? So love to hear what you think. What we have been doing is first to restrict the population to those with the indications, either type 2 diabetes or obesity. Elisabetta Patorno conducted a validation study of the obesity algorithm, and that's where she found a 50% or 40% sensitivity, but a really high positive predictive value of over 87% for obesity in claims. Then we use active reference groups to with Equipoise, so not just the person has diabetes type 2, but is on second-line treatments or has been before pregnancy already on metformin and insulin. So we pay attention to the progression of the diabetes. Then we use IPW or propensity scores, weights, or other approaches to balance the rest of the characteristics, including the insufficient, like incomplete, but some information we have on BMI. And then with the information from a subsample of data that we had with labs, including hemoglobin A1C, and a subsample of the data where we had records like BMI, through connection with the medical records at the Brigham and Women Mass General system. We validate the algorithms and then try to quantify how much that can affect our estimate using bias analysis. So in summary, we do need to use real-world evidence to study these medications in pregnancy, but acknowledging that we are outside the clinical trial territory, so that every association or lack of association that we find can be due to chance, just random, because the numbers are not huge, to biases, or if there is no other better explanation, we can assume that it is causal, meaning either that there is an effect or there is not effect. So the results are a question of precision, a question of numbers, and a question of having the right data, high quality data or enough quality data, and a question of the methods that we apply. And I wanted to mention the numbers because since there are going to be a large number of pregnancies exposed, we need to produce, I think, information as soon as possible. So how do we do that? With collaborations, linking with other groups, other studies, like our Nordic colleagues, other healthcare databases. And I think the field overall in pharmacoepi is also seeing how can we better coordinate or with the randomized trials to see if we can kind of continue the follow-up, including the potential pregnancies through real-world evidence, for example, or like registries or databases. In conclusion, other than the specific topic of today, I will say that generating useful real-world evidence to inform clinical and regulatory decisions in pregnancy is a question of using the robust best methods that we have today to produce valid estimates, and that includes using data that is fit for purpose, meaning that has sufficient quality, even when it's not going to be perfect, and then applying the correct causal inference methods, including not only the analysis, but also a robust protocol that try to avoid biases. And then also question of numbers, and to attain precise estimates with narrower confidence intervals than the ones I was able to produce so far. We were able, sorry, this was a team effort, and a question of time to produce rapid responses. And that's all I have. I would love to hear from you any like questions and recommendations and ideas to move forward.